Hello everyone, I Govinda Gahine, lecturer in mining department at Chhattisgarh Swami Vivekanand Technical University, Bhilai. Today I will discuss lecture number 26, Mine Health and Mine Occupational Diseases. A worker working in mine may have to face some occupational health hazards, mainly due to environmental and working conditions. The main diseases are first nystagmus, second ankylostomycetes, third pneumoconiosis. In the pneumoconiosis, the following diseases are involved: first silicosis, asbestosis and sidrosis. The silicosis, asbestosis, sidrosis, they are resulting from dust. So first nystagmus. This is peculiarly an underground miner's disease. The terms nystagmus apply to a disease in which the muscles and nerves of the eyes are affected and there is an abnormal movement or oscillation of the eyeballs. Where naked light are used as in metal mines, the incidence of nystagmus among miners is low. Electric cap lamps have also brought down the incidence of nystagmus in coal and metal mines. Before the introduction of electric cap lamps is coal mines. The older type of flame safety lamp with less than 0.6 candle power had resulted in nystagmus among a large number of coal mines. It is stated that a miner suffering from nystagmus cannot see the gas cap in a flame safety lamp. The supervisory staff in coal mines are therefore required to undergo periodically eye testing once in 5 years. The remedy to avoid the disease lies in proper illumination. Next is ankylostomycetes. Ankylostomycetes or miners are anemia is practically the same disease as hookworm disease and is caused by a thread like blood sucking worm which enter the body through the skin. Miners working in unsanitary conditions and cutting coals, standing in dirty water with bare feet over long hours may be affected by this disease. The symptoms are pain in stomach, loss of appetite, constipation followed by diarrhea and dysentery. A person seriously affected looks anemic. Positive knowledge is obtained by examining the stool for hookworm egg. Next is related from dust disease. So first we will discuss about dust hazard in mines. Before appreciating typical diseases arising from inhalation of dust in mines, one should understand the dust hazards. The hazards of coal dust as a potential cause of explosion has been described in the chapter of explosion. Airborne dust of coal and other rock in mines have harmful physiological effect. It is now well established that the incidence of pneumoconiosis, silicosis, etc. depends upon the period of exposure to dusty surrounding and nature and concentration of dust. The dustiness of the air, the quantity of dust contained in it is stated in two ways. First, as the number of dust particle per centimeter cube of air. This method is as the dust count method. As the number of milligrams of dust per meter cubes of air. This is known as the weight of gravimetric method. The idea of dustiness of a surrounding can be formed from the following figure obtained after number of observation. Dwellings about 1.5 mg per meter cube, stone sites about 22 to 45 mg per meter cube, cement works and ore treatment plants about 130 to 200 mg per meter cube, and suits during cold loading by conveyor about 5 to 10 mg per meter cube. For conversion of weight standard to dust count standard, it is accepted that 1 mg per meter cube corresponds to about 200 particles up to 2 mu across per centimeter cube, means 1 mu is equal to 1 micron is equal to 1 upon 1000 mm. Next is pneumoconiosis. So, pneumoconiosis, dust in mines and other dusty place of work in factories causes diseases of the lungs, which are grouped under the general terms pneumoconiosis. It is Greek word, means pneumon means lungs and conic means dust. The term is applied to all conditions in the lungs resulting from the inhalation of dust over long period. But in recent years, distinct terms are being used to denote the disease caused by specified dust like silicosis by silica or cause dust, siderosis by iron oxide dust, berylosis by beryllium either in the form of dust or fume, asbestosis by silicates of magnesium, etc. Dust from limestone, shale and some metallic ores are not harmful, although it is generally agreed that anthracite and bituminous dust do not produce lung disease. They do cause asthmatic condition when breathed over a long period. The lung diseases caused by dust may exist for considerable period without producing symptoms or impairing physical efficiency. Next is classification. The classification of the pneumoconiosis may be made according to the physical nature of the dust or by the type of tissues response to the particular agent. Others consider the clinical and other feature of the particular dust disease. The inorganic dust producing the disease are classified as: first, fibrosis producing. Silicosis and asbestosis are the most important in this group. These dusts are slightly soluble. Second, non-fibrous producing. Anthraconosis is the chief example in this group. These dusts are inert and become encapsulated in the tissues or absorbed but do not produce fibrous tissues. Next is toxic and irritant. This groups comprises lime, dischromate compound, lead, mercury and other heavy metals. These are corrosive and cause several local reactions. If absorbed into the body in sufficient amount, generalized toxic effect appear. The dust and also the vapor of these substances are harmful. Next is silicosis. This is the most disabling and worst of all the dust diseases. It results in fibrous tissues of the lungs and may ultimately lead to tuberculosis. Workers engaged on stone drifting, tunneling, rock drifting at the surface in quarries or underground, and stone crushing are most prone to silicosis. So also are the workers engaged in grinding and polishing industry and in iron and steel industry. It has been found that particle of silica measuring 0.5 to 2.5 micro in diameters are most produce damage. Dust particles of silica are partly transformed in the alveoli into poisonous silicic acid H2SiO3 which passes into the blood. Next is asbestosis. Asbestosis is a kind of pneumoconiosis which results from the inhalation of hydrated magnesium silicate. An important feature of this disease is the presence of asbestos body in the lungs and sputum. Fibrosis of the lungs develops faster in asbestosis than in silicosis, and in extreme cases a person may die on asbestosis within 5 years of the onset of symptoms. Next is siderosis. Siderosis is caused by inhalation of iron dust. The pathologic changes are due principally to the presence of silica in iron ore. Electric arc welder are also suffer to develop this type of disease due to the fact that the electrode used in the process are composed of approximately 99% ferrous material. The fume arising from the electrodes contain inorganic substance, particularly finely divided iron oxide, iron ore dust through it produces. Pneumoconiosis usually does not show fibrous and is generally non-progressive and non-disabling through the alveolar walls, indicates their pigmentation and consequent thickening. If, however, iron ore dust contain some free silica, fibrosis will result. Next, anthraconosis. Anthraconosis occur in coal miners and in city dwellers exposed to dusty atmosphere containing large amount of smoke. The term means black lungs. The particle of carbon which find their way into the lungs produce a phagocytic reaction similar to that in silicosis. However, the carbon particles are inert chemically and do not cause local injury to the lung tissues. The foreign material may be carried to the liver, spleen, bone marrows, lymph nodes and other organs. The affected organs are dark in color but show no local reaction unless silica is also present in mines worker subjected to inhalation of coal and silica dust mixtures. Anthraconosis develops characterized by extensive cystic fibrosis and marked emphysema. These patients show a high degree of tuberculosis. Miners in underground working having poor ventilation are prone to this disease, and the symptoms may be observed only after 15 to 20 years of working. According to British standard, the concentration of coal dust of particle size 1 to 5 should not exceed 850 particles per cc. It is now well known that the capacity of dust to damage the lungs depends upon the content of free silica in it. According to Russian standard, the permitted content of silica dust in the mine air should not exceed 2 mg per meter cube. The following tables gives the permissible concentration. The permissible concentration of non-toxic in mine dust is left hand side is the type of dust and right hand side is the permissible concentration in milligrams per meter cube. So, first is dust containing more than 70% free silica, the permissible concentration limit milligram per meter cube is 1. Dust containing 10 to 70% free silica, the permissible limit is 2.0. Next, coal or coal measuring dust containing more than 10% free silica, the limit of permissible limit is 2.0. Coal dust containing less than 10% free silica, permissible concentration is 4.0 milligram per meter cube. Next, coal dust containing no free silica, the permissible concentration is 10 milligram per meter cube. In British standard laid down that the concentration of airborne stone dust of particle size of 0.5 to 0 micron must not exceed 450 particles per cc. The same standard is accepted in India. Mouth breathers are more likely to acquire the disease than nasal breathers with normal condition of the nose and pharynx. The symptoms of lung disease in general and of silicosis in particular are: first stage is the patient may look apparently healthy but not slight shortness of with very exhaustion and has dry cough. Stage 2, definite shortness of breath, pain in chest, dry cough in morning, sluggish movement and a reduced capacity for work. Stage 3, pronounced shortness of breath, frequent dry coughing, frequent tendency to speed, pulse rate increased and capacity for work greatly impaired. The above three stages can be detected by radiographs of the lungs. The last stage in silicosis is emphasized by large shadows corresponding to area of dense fibrosis. Alkalines increase the effect of dust, while coal dust, aluminum and other minerals apparently retard the development of silicosis. The principle of aluminum therapy depends on the fact that particles of metallic aluminum or amorphous hydrate alumina, when engulfed in some phagocyte cells along with silica dust, neutralize the effect of silica and thus arrest further progression of fibrotic tissues reaction. Aluminum ordinarily has no harmful effect on lung tissues, but heavy dose make the lung more susceptible to tuberculosis infection. The remedy in prevent lung disease lies in: first, reduce dust formation at places where workers are engaged. Second, collecting the dust by suitable dust traps. Third, examine the dust concentration at working place at regular intervals by suitable instrument and taking corrective steps. The way to reduce airborne dust in underground mines have been described in earlier pages. The instruments to assess the dust concentration in mine will therefore be described here. Dust sampling method and instrument. In order to take suitable prevent and suppression measure for allying dust in mines, it is necessary to have a suitable device to estimate or sample airborne dust likely to be breathed by the underground workers. The sample of the dust collected should be able to give knowledge of the dust concentration in the dangerous site range. The process of estimating by suitable instruments or device the dust concentration in the collected sample is known as sample of dust. Dust sampling methods so far developed can be classified as follow. First is filtration method, second is sedimentation method, third is thermal precipitation method, fourth is impingement method, fifth is electrical precipitation, sixth is optical method, seven is impaction method, and last one is centrifuging. Mass concentration of dust can be obtained by different weighting of suitable filters before and after the collection of sample. Dust collected by filtration can also be spread on glass sides. Examine under the microscope for determining the particle concentration and size, but this gives unreliable results because of the difficulties of suitability dispersing in the dust on a microscope slides. Paper filters are usually made in the form of rigid thimbles, such as the Soxhlet thimbles, through which air is drawn either by a hand pump or by a compressed air injector, the latter being necessary for collecting large samples. Paper thimbles have been claimed to have collection efficiency of 98%. The method of thermal precipitation utilizes the principle that when a body surrounded by dusty air is heated, a dust free zone is produced around the hot body. The extent of the dust free zone depending upon the temperature gradient between the hot body and the surrounding air. If such a zone is interpreted by two glass cover slips and the illustrating principle current of dust air allowed to enter between them, the dust in the air gets deposited on the cover slips at the point and where it remains attached by molecular attraction after the sample has been collected on the cover slips. The latter, the mounted on 75 mm into 25 RAM microscope slide and waxed to it so that the dust is enclosed between the two glass surface. The slide is then counted under a high power microscope. Counting is done with the help of suitable calibrated reticule introduced in the eyepiece. The thermal precipitator is an accurate sampling instrument. It collects a representative sample over a reasonably long duration, and the low sampling velocity does not affect the aggregates, but it involves skilled operation and arduous microscopic counting. The method of impingement utilizes the principle of inertia precipitation of dust when a fast moving stream of air impinges on a surface. The most common used instrument based on impingement are the conimeter, The conemeter is a very handy, compact and sturdy instrument suitable for routine dust sampling, but it is a snap sampling instrument collecting only 5 centimeter cube of sample over a period of half second, thus providing a sampling velocity of the order of 160 meter per second. Hence, for accuracy in computing average dustiness at a particular place in the mines, it is necessary to take a large number of samples. The electrical precipitator essentially consists of a charging wire maintained at high negative potential of about 12,000 volts and surrounding by an earth concentric cylinder. Dust laden air is drawn through the cylinder by a fan at a constant rate. The dust particle, when passing through the instrument, get charged and are drawn to and precipitate on the inner surface of the earth cylinder. These instruments, like the filtration device, has a large sampling capacity and is suitable for collecting large quantities of dust for chemical analysis. The mass concentration can also be determined by noting the difference in weight of the cylinder before and after collection of dust. The optical method utilizes the property of scattering of light by suspension of fine particles. The intensity of scattered light is proportional to the surface area of the particle, a fact well borne out in practice. The instrument based on this principle is the tyndalloscope, very commonly used in German coal mines for routine dust sampling purpose, mainly because of its cheapness as well as quickness and ease of operation. Thank you.